Okay, in this video we're going to be looking at how to differentiate the trigonometric functions, that is sine, cos and tan. I'm going to start just by stating the rules. Okay, so here are the rules. I've written them up on the board. Sine x differentiates to give cos x. Cos x differentiates to give minus sine x. And tan x differentiates to give sec squared x. Okay, so those are the rules. Let's just try to practice with them with a basic question. Let's say we've got let's say we've got y is equal to 2 sine x minus 3 cos x plus tan x. Well, if we differentiate that, then the sine x will differentiate to give cos x, so we get 2 cos x. The cos x will differentiate to give minus sine, so we got minus 3 times by minus sine, so that's be plus 3 sine x. And then we've got tan x differentiates to give sec squared x. Okay, so that's a fairly simple example. Let's try something that's a little bit more tricky. So we can go down. Let's say we want to differentiate y is equal to sine x times by cos x. Now here what we've got is we've got two functions which are multiplied by each other, right? We've got one function here, sine x, but another function here, which is cos x. And when we've got two functions multiplied together, then this is going to be a product rule. Okay, we're going to call that one u, and call that one v. And remember that the product rule is v times by du dx plus u times by dv dx. So we've got to differentiate each of these terms. So u is sine x and v is cos x. So that means if we differentiate u, we're going to get cos x. And then if we differentiate v, we will get minus sine x. Okay, so then what's dy dx? Well, dy dx is v cos x times by du dx, which is also cos x, plus u, which is sine x, times by dv, which is minus sine x. And if we were to simplify all of this, then what we're going to get is we're going to get cos squared x minus sine squared x. And that would be our answer, right? That's how we differentiate that. Okay, let's try one more before we finish. Let's say in this case, I've got y is equal to tan x divided by 1 plus sine x. In this particular case, we've got a quotient rule because we've got one function divided by another function. So we're going to call the top function u, and we're going to call the bottom one v. And remember that the quotient rule is v du dx minus u dv dx all over v squared. So we're going to have to differentiate both the u and the v. So we've got tan x here, and we have 1 plus sine x. So if we differentiate those, the tan x will become sec squared x. And the 1 plus sine x, well, 1 differentiates to give 0. The sine x will become cos x. So if we substitute this into the quotient rule, we're going to get v times by du minus u times by dv. And this is all going to be divided by v squared. Okay, now of course we can simplify this, and it'll be helpful to go through that. But at the moment, I just want to get you to understand how to differentiate the trigonometric functions a bit more simply. But for example, for those of you who want to think a bit more, we can look at this thing here, tan x cos x, and we should remember from our trigonometry chapter that this thing can be simplified, because if we remember, tan x is the same as sine x over cos x. So if we've got tan x times by cos x, the cos's will cancel out and we'll be left with sine. But we'll deal with something like that a little bit later. Okay guys, so that's how to differentiate the trigonometric functions. I think it's key just to remember the rules that we had at the beginning. I hope that was helpful. I'll see you again next time.